In this video, we're going to take a look at provider bridging. This is covered by the IEEE standard of 802.1ad and is also sometimes referred to as Q-in-Q encapsulation. So what problem are we trying to solve here? Well, imagine you are a service provider who's running a multi-tenant network providing layer 2 services to multiple customers. The 4094 VLANs that you get with 802.1q encapsulation aren't going to scale to very many customers if those customers require multiple VLANs. So we need a different technique to be able to have a much larger layer 2 namespace to play around with so that we can support many customers, each requiring many VLANs when we're operating a service provider network. And this is what provider bridging allows us to do. We're solving this problem by having stacked VLAN tags in the Ethernet header, much like we could have stacked MPLS labels in an MPLS environment. I've illustrated this on the top portion of the board here. We have a typical Ethernet frame. We've got our IP packet, and it's encapsulated in an Ethernet header where we've got our destination MAC address and our source MAC address. What we're doing with provider bridging is we're inserting two VLAN tags here. We've got a inner VLAN tag, which is sometimes called the C tag, the customer tag, and this has a tag protocol ID the same as an 802.1q VLAN of 8100. The key here is that we're then adding an additional outer VLAN tag, an S tag, a service tag, and this has a different tag protocol ID value of 88A8. And what we're doing here is the C tag, the customer tag, these are the customer specific VLANs, the VLANs that the customer are going to use on their own site. And then the S tag is the tag that's relevant to the service provider, and this tag is what identifies each of the individual customers that this particular Ethernet service provider is servicing. So this is the frame format. What do the different elements of the network architecture of a provider bridging network look like? This is what we have outlined on the bottom portion of the board. And the elements are fairly similar in role to what you'd expect in an MPLS service provider environment. We have our customer devices. In this case, we have customer switches on the far edge, and then we have our service provider portion of the network in the middle. We have our provider edge bridges. So these are the devices that are interconnecting to the customer switches. And what they're doing is, on receipt of a frame from a customer, they're pushing an S tag onto the frame. This frame then traverses through the service provider network, and on the egress provider edge bridge, we're popping that S tag off and passing a standard 802.1q encapsulated packet to the customer. And then on the intermediary portion of the provider network, we have provider bridges, and they're performing standard layer 2 switching on the S tag, the outermost tag of the frame up here. If this provider was interconnected with another provider, or there were two portions of a provider's network interconnected, provider bridges can be swapping the S tag to a value that's locally relevant to the network that he's passing that Ethernet traffic onto. And so, as you can see, with this addition of a outer S tag to a Ethernet frame, we can support a very large number of customers, and those customers can have a very large number of VLANs in a service provider Ethernet environment. And this is a quick overview of provider bridging.